Welcome to the C2 Pipeline Innovation and Curiosity Center Impression Evidence Fingerprints Lab. By the end of this lab, you should be able to understand the history of fingerprinting, understand how fingerprints form, identify different types of fingerprint patterns, understand the different methods of fingerprint detection, and use a lifted print to identify the subject. The major goal of criminal and civil investigation process is to identify people. Fingerprinting is widely used. All individuals have a unique set of fingerprints, even identical twins. At this time, fingerprint ridge characteristics are considered to be individual evidence. Dactyloscopy is the science of comparison of friction ridge structures. Ridgeology is the science of ridge analysis. Around 8 AD, deliberately impressed fingerprints have been found on Chinese and Japanese documents. In the 1870s, William Herschel, a British official, required palm prints and impressions of the right index finger from locals in India for every contract he made. Alphonse Bertillon was a French police expert who devised the first systematic method of personal identification. Bertillon's system was known as anthropometry. Detailed description and precise measurements of the body, including full-length photographs. The system failed after the Will West case of 1903. The end of the use of the Bertillon system came with the Will West case. Will West was taken to Leavenworth Prison. The records clerk ran his Bertillon measurements and found they closely matched another prisoner who was serving a life sentence. His name was William West. Even the photograph of William West closely matched the new prisoner, Will West. Fingerprints of both were taken and found to differ. The value of fingerprint identification was established. In 1882, Sir Francis Galton asserted all fingerprints were unique and did not change through life. He categorized patterns of fingerprints into loops, arches, and whorls. He also developed a classification system that allowed for a person's fingerprints to be placed in smaller groups. Sir Edward Henry. He developed an alternative classification system that was adopted in England. His system has been modified and is still in use in the United States and Europe. It uses 5 classifications to put a set of 10 fingerprints into one of thousands of classes. FBI added additional classes to make searching more practical. Henry used certain characteristics of each print. One was how many whorls were present. Fingerprints arise from dermal papillae, the layer of cells between the outer skin, the epidermis, and the inner skin, the dermis. A person's fingerprints are formed when they are a tiny developing baby in their mother's womb. Pressure on the fingers from the baby touching and their surroundings create what are called friction ridges, the faint lines you see on your fingers and toes. Friction ridges start at 8 to 10 weeks of gestation and become fully developed by the 17th week. Friction ridges are a series of hills, the ridges, and valleys, the furrow, as shown in this picture. They are on the skin of hands and feet. As friction ridges develop, perspiration glands are formed and connect to pores in the epidermis. Pores release waste materials such as sweat, oils, proteins, fats, and other materials. When a finger touches a surface, these wastes are deposited, forming a fingerprint pattern that matches the friction ridge pattern of the individual. The types of fingerprints found at a crime scene are as follows. Patent prints, which are prints that are easily seen, such as those left by blood, grease, dirt, or fresh paint. Plastic prints are found as impressions on wax, clay, or butter. Latent prints are invisible to the naked eye. The three major types of fingerprint patterns are arches, loops, and whorls. As shown in this picture, the white highlight shows a loop. In the second picture, the white highlight shows a whorl. And in the last picture, the white highlighting shows an arch. Fingerprint patterns are characterized by the presence or absence of a delta, which is a triangular intersection of ridges. An arch has no deltas. A loop has one delta. And a whorl has two deltas. Arch patterns differ in severity of the slope of the arch. There are two types of patterns, a plain arch or a tented arch. As you can see, the tented arch is more pointed. 5% of fingerprints have these types of arches. Loop ridges enter from either side of the finger, recurve, and pass back along the side from which they entered. Loops are identified by the direction the loop opens to, known as radial, the thumb side, or ulnar, the little finger side. Nearly 2/3 of prints are loops. Whorls are many circular ridges are common. There are 4 types of whorls: the plain whorl, the double loop whorl, the central pocket loop, and the accidental whorl. These types of ridges make up about 30% of fingerprints. More about whorls. A plain whorl is located between 2 deltas of the whorl pattern and has a minimum of 1 ridge that is continuous around the pattern. The central pocket loop whorl is not located between 2 deltas of the whorl pattern and has a minimum of 1 ridge that is continuous around the pattern. The double loop whorl is made up of 2 loops that swirl around each other. And the accidental whorl is a pattern that combines 2 or more patterns, excluding the plain arch, and/or does not clearly meet the criteria for any of the other patterns. Patent and plastic prints are generally easy to discover. The major challenge for investigators lies in attempting to recover latent prints from the crime scene, those prints which cannot be seen with the naked eye. Different surfaces present different challenges. Locating and visualizing prints can be done by the following methods: reflected ultraviolet imaging system, powder dusting, or chemical enhancement methods such as ninhydrin. Crime scene prints compared are known prints using the 10-print card, which is used to collect fingerprints, a rolled print, which is a fingerprint rolled from cuticle to cuticle. They tend to look rectangular, and tap prints, fingerprints that are tapped in ink and then placed at the bottom of a 10-print card. They tend to look oval in shape. Live scan, or digital fingerprinting, came about in the 1990s. It replaces the inked 10-print card. The machine captures the friction-ridge image and stores it digitally in a computer database, making searching much easier. Altering your fingerprints. In most cases, the act of alteration will make the fingerprints easier to identify by adding cuts or scars to the ridge structure. An example, John Dillinger in the 1930s put acid on his fingers, but he did not destroy his ridges completely. This picture shows how a person glued another person's fingerprint to their own. Why do you think this wouldn't work? If you thought it wouldn't work because the glued fingerprint is not live tissue, you are correct. The tissue would eventually dry up and it wouldn't look like a human fingerprint any longer. Let's start our fingerprint investigation now.